Hi everybody, it is Friday, November 2nd, and I'm sorry I'm out, but I have mono and I'm not allowed to come to school, at least until Monday, but depending on what, anyway, I might be there Monday, might not, but I should be there Monday. Alright, so this is the start of trigonometry. So a long time ago, pre-calculus used to be just called trigonometry. So trigonometry is the biggest part of pre-calc. It's useful. You'll be seeing it again in Calc 1, 2, and 3. So trigonometry is the study of the triangle measures. Okay, trigonometry, triangle measures. So back in geometry, you usually focused on anything 0 to 180. Well, in trigonometry, you can go 0 to 1,000 if you want, 1,080. You can go all the way around the circle more than once. Okay, so you're going to go past 180, and we're going to be working with lots of different angles. So study of angle measures is what we're doing. So this is appropriate for section 14.1 to be called angle and angle measure. Okay, because that's what we're doing in trigonometry. So again, today is 11/2. Go ahead, date your notes. All right, so today we are going to be drawing angles in standard position. That's very important to know how to draw an angle. We're going to find the initial side and the terminal side of an angle in standard position, and we're going to identify coterminal angles. So trigonometry and angles. An angle consists of a fixed ray called the initial side and a rotating ray called the terminal side. So let's just start that right now. How about everyone go ahead on the side here and draw an X and Y axis. Okay, this is our X axis, this is our Y axis. So the initial side is always going to start on the positive X axis. So we kind of do this and then we just go ahead and draw an arrow. So this initial side is like 0 degrees. Now, a rotating ray can stop anywhere. If it stops anywhere in this first quadrant, it's going to be something 0 to 90. If it stops somewhere over here, it's going to be somewhere between 90 and 180. It could keep going between 180 and 270, or it could go 270, 360. So let's just say we stop somewhere in between 180 and 270. We give it a little arrow. This arrow shows us which direction it's going. So this one is going clockwise. Oops, excuse me for 1 second. Hello? This is Mary. Uh-huh. Okay, sounds good. Thank you. Bye. Okay, sorry about that. So anyway, this is the initial ray. So this is our initial side right here. And this is our rotating ray, and it's going counterclockwise because the clock runs like this. So this is counter to that. So it's going backwards what a clock does. So it's called counterclockwise, and that means it's positive, by the way. Counterclockwise is positive angles. And then you draw this second side right here. This is called the terminal ray or terminal side. Make sure it's an arrow. So you have initial side, terminating side, and then rotating arrow. These three things. That's how you draw an angle. Okay, and so this angle would be somewhere between 180 and 270, and that's how you would draw an angle. Okay, so standard position. The vertex is at the origin. Vertex is always at the origin. And the initial side is always on the positive x-axis. Okay, so counterclockwise rotation represents an angle with a positive measure, and a clockwise represents an angle with a negative measure. So here's an example right here. So on this first picture, this is the initial side. Here's your rotating ray, and here's your terminal side. That is indicating a positive angle. So what would you guess this one to be? If this is 90, This one looks like it's right in the middle. So this is probably about, we'll call it theta. We use Greek letters to indicate angles. That's a theta. And you could say that theta is about approximately 45 degrees. Okay? So in this one, here's your initial side. So this time it's going clockwise, so this is negative. So this is negative 90. This is negative 180. And then you went about another 45. So it's like negative 180 and another 45 is about negative 225 degrees. That's what that angle would be. So if we call this theta, that'd be about negative 225 degrees. So what we're going to do is we're going to draw each angle described below in a standard position. And then we're going to give the degree measure of the angle and tell what quadrant it is in. Okay? So it says 1/4 of a complete counterclockwise rotation. So here's what one counterclockwise rotation looks like. That's one. That's the whole thing. That's 360 degrees. But we're only going to go 1/4 of that. So 1/4 of that would be 1/4 of 360, which is 90. So if we're drawing a 90-degree angle, you're going to draw an X and Y axis, positive ray, and you're going to go up to 90 right here, rotating ray, and then terminate. So you have initial, terminating, or terminal side, and then you have this rotating ray. That's how you would draw a 90-degree angle. All right. 1/2 of a complete clockwise rotation would be 1/2 of negative 360, because clockwise is negative, which is negative 180. So how would you draw negative 180? So you start with your initial side. There's negative 90. There's negative 90, 180. There's negative 180. And that's your terminal side, and that's how you would draw a negative 180. So it's kind of like a straight line. Now, if you wanted to draw 4 complete counterclockwise rotations, mathematically that means 4 times positive 360, which is what? I don't know. I have to get a calculator. 4 times 300 is 1,200. I think it's going to be 1,440. 1,440. Let's make sure. My math. Yeah, okay, 1,440. So how would we draw that? So you have initial, right? So you start here. Start in here tight around the origin here, because we're going to make it look like a cinnamon roll. That's 1. That's 360. This is 2. That's 720. This is 3. That's 1,080. And this is 4. 1,440. So it should end back at the positive x-axis. Okay, so that's what 4 complete counterclockwise rotations looks like. But the actual angle of that is 1,440. Oh, you know what? We were supposed to say what quadrant these are in. This one right here, this first one, was not in a quadrant. It's on an axis, so not in a quadrant. So not in a quadrant. This one was not in a quadrant. That's pretty stupid to ask this question since none of them are in a quadrant. This one's considered the positive y-axis. This is considered the negative x-axis. This one's considered the positive x-axis. None of these are in a quadrant. This one's going to be in a quadrant. So 2 1/3, by the way, 2 1/3 is really 7/3 times negative 360. This goes into negative 120, and that's going to be about negative 840. Okay, so this is what this is. 2 1/3 of a complete clockwise rotation. So we have initial side. There's 1 complete. There's 2 complete clockwise, and then a third. A third of 360 is about 120, so we're going about another 120. There's 90 and about 30. Terminal side, draw it in. And that's also, not only, if I just counted by rotations, but if you're counting negative 840, you'd be going negative 360, negative 720, and about another 120. And that's how you draw it. And this, by the way, is in the 3rd quadrant. Remember how quadrants are labeled? Let's go over here. This is the 1st quadrant. This is the 2nd quadrant. This is the 3rd quadrant. And this is the 4th quadrant. Remember that? Okay, coterminal angles. What is a coterminal angle? They are angles formed by different rotations but with the same initial and terminal sides. The formula to find coterminal angles is take your initial angle that they give you and just add 360 to it. If you want more than one, add 360 maybe twice, add 360 3 times, or add 360 4 times. Or you could add 360 times -1, so that would be like subtracting 360, subtracting 720. So if n is negative, you're actually subtracting. So find four coterminal, 2 positive, and 2 angles with -100. So you'd have -100 plus 360 times 1 would be 260. That's one of them. Then you could have -100 plus 360 times 2, which is the same thing as 720, and -100 would be 620. But we could also go the other way and go 360 times -1, which would be -460. And we could go -100 plus 360 times -2, which is that 720 and 100, 820? Negative. And that's how you do it. So how about you guys try? 45 plus 360 times 1, 45 plus 360 times 2, 45 plus 360 times -1, 45 plus 360 times -2. Why don't you guys go ahead and figure all those out? You do it, and then I'll start doing it myself on my calculator. First one, 405. So if you said 405, you are right. Second one, 765. I really just added 360 to the first, this 405. And then if you had 45 minus 360, that's the same thing as -315. And then if I subtracted another 360 from that, it's -675. So basically what they're saying is all four of these angles land in the same spot. That's what coterminal means. All four of these land in the same spot. Coterminal. Let me give you an example. Let me just show you this -100. -100, here's -90. -100 is about right here. Okay? So if I said to draw 260, for example, 260 would be right here. Do you see how it's in the same spot as this one? Coterminal means they land in the exact same spot, same quadrant. If I said to draw 620, 620 would be 360, 450, 540, and 620. Same spot as the other two. They're all in the same spot. That's what coterminal means. Same spot, same quadrant, everything. Sometimes angles are given are too large or too small, so we want to subtract 360 in or add 360 till we get an angle between 0 and 360 that's easier to draw. So the real purpose for a coterminal angle is to work with smaller angles that are user-friendly. So, for example, if I said to draw -1350, or just tell me what quadrant, if I just said what quadrant is it in, then you might want to just, since it's negative, you might want to just start adding 360 until you get an angle that's user-friendly. So let's do that. So let's punch in on our calculator -1350. Okay, you see it? I'm going to add 360. It's still negative. Can't see that. It's -990. So we're going to add 360 again. And then I have -630. And I'm going to add 360 again. So we're getting closer. I could draw -270. That's down. Actually, that's up top. But it's still negative. So I'm going to add 360 one more time. And it's 90. So 90 is the angle that is coterminal. So they're both in the same spot. But this is the one that's easier to draw. So it says find an angle. So if I wanted to draw this, it's right there. Okay, it's going to be up there at the top. So they're the same thing, same spot. Just one's 90, one's -1350. But if I was drawing -1350, it'd be like 1, 2, 3. I think it's like right here. But it's going to still end up there. But we don't need to do that. We can just do that on our calculator, get it closer, and work with that. So 890. I don't know where 890 is to you. But what we can do is we can punch in 890 in our calculator. This time we're going to subtract 360. See, 530 is still too big. So we're going to subtract 360 again. So I'm just subtracting 360 each time. This is 170. Now 170 is definitely an easier angle to graph. So 170 is our answer. If I wanted to draw 170, it's about right there. Okay, it's easier to draw than 890. And the last part of this is arc length. Arc length is like if you had a pie. Let's say you have pumpkin pie here. And you decide to cut a slice right there. Arc length is the crust. It's this thing right here. Okay, and it's arc. It's arced. It's not straight. Okay, so to figure out what this arc length is, we're going to call it S, by the way. Arc length is S. This is the radius. This is the angle. We can figure out the arc length using angle, the radius, and figure out this. So back in geometry, this was the formula that you guys did. Arc length was S. So right there, S. You said, well, you do a portion of 360, right? That's what it is. It's a portion of 360. And then times 2 pi r. 2 pi r is the circumference of a circle. And these two things are the same. So it's a portion of that. What portion of that is that? So this is what it kind of looks like in geometry. You had your n, which is your degrees, times pi over 180 times r. Well, we don't do this formula. We don't do this formula. We do this right here. S equals r theta. Okay? Radius times theta. But the theta has to be in radians, which you haven't learned yet. So why am I teaching this yet? Hi. Yeah. So radians, just real quick. If you had degrees, if you had n degrees and you wanted to go into radians, what you're going to do is you're going to multiply it by pi over 180. Okay? Pi over 180. So that's why they use this formula. N is your degrees times pi over 180 changes it over to radians times your radius. So if you want, you can. I guess you could just use this formula. Okay, this is your degrees, given degrees, times pi over 180 times radius. This is how you find your arc length. But if it ever gives it to you in radians, you just multiply the radians times radius, and you're done. So let's look at this problem. Find the length of AB. Okay, so AB is your arc length. So to the nearest hundredth. So what you have is that your angle is 60 degrees, and your radius is 8 inches. Okay, so we'll use this formula right here. So you're going to go 60 degrees times pi over 180 times r. Okay, right here, 60 times pi over 180 times 8. So let's do that. We have 60 times, see that? I'm going to do parentheses. Pi is above the, right here. Pi is right above that caret sign right underneath clear. So press second caret. Pi divided by 180. Notice I put that in parentheses. I don't know why. I don't think it matters, but I did. Because it's a fraction. Times your radius, which is 8. And you get 8.377. So we'll go 8.4. So the length of 8B is about 8.4 units. I don't know if it's inches or what. But that's how you do it. So in this problem, find the length of arc AB. So it's from here all the way over here. So we're trying to find that. And we're going to do 210 times pi over 180 times the radius, which is 30. Now if you wanted to have fun, you could start cross-canceling a bunch of stuff here. Again, easier to do on the calculator, or you could just punch this in the calculator. Like if I was doing this, maybe I'd go 30 goes into 180 6 times. And let's see, 3 goes into this. Actually, 2 goes into this 3 times. 2 goes into this 105. And 3 goes into 105 35 times. So that means it's 35 units. So let's do that on the calculator. We have 210 times parentheses pi divided by 180 times 30. Oh my gosh, was I that wrong? So I'm wrong. Oh, you know why? Because I forgot the pi. It's 35 pi. Sorry about that. It was 35. I forgot the pi, guys. 35 and pi. So that was what this is. This is 35 times pi. This pi is 3.14. So my bad. It's 35 pi, or It is 109.96. Okay, a wheel with radius of 20 inches rotated 80 degrees as it rolled along the ground. How far did the wheel travel? All right, we're not even going to do these because we haven't done. I don't know why this is even in this section. I think I just wanted to get you guys used to this because This is coming up later on. I don't even think this is in this section. I think this is why I added it. All right, I'm done. Do your homework. Homework's in the book.